Hello everybody. Today I can find the missing sides of special right triangles using the given ratios. Now this will be given to you on your reference sheet when you take your SAT exam. If you're watching this for a different course, then it will not be given to you on your reference sheet. But for the SAT, this is given to you. So I'm going to kind of show you where they're coming from, and I'm going to show you how to use them. So let's start with the 30, 60, 90. So first off, I'm going to give you that this side is 1 and this side is 2. And I want to find the missing side. So to find a missing side, I do Pythagorean theorem. A squared plus b squared equals c squared. Let's call this x, this side right here. So it'll be 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. Isolate the x squared. X squared equals 3. Take the square root to get rid of the squared. I'm not going to put plus or minus since we're dealing with distances here. And I get radical 3. So what that means is, let me just erase this now. What that means is that this is the ratio that the sides of a 30, 60, 90 triangle are always in. Now I can multiply each side by anything that I want, but if I multiply a side by something, I'm multiplying all the sides by that. For example, let's say this side was 3. This side is always double that, and this side always just has a rad 3 tacked on. So what I come up with, and this is what's on the reference sheet for the 30, 60, 90, is the small side is x, the big side is 2x, and then the long leg is x rad 3. And basically what that means is the small leg is half of the hypotenuse, or the hypotenuse is double the small leg, and then the large leg is the same as the small leg with the radical 3 tacked on. Now let's come up with the 45, 45, 90. So because the angles are the same, that makes it an isosceles triangle, which means that the sides are the same. So I'm going to call this 1, I'm going to call this 1. And I'm going to, again, do Pythagorean theorem to find the third side. A squared plus b squared equals c squared. 1 squared plus 1 squared equals x squared. 1 plus 1 equals x squared. 2 equals x squared. Square root. Again, I don't have to write plus or minus since we're talking about distance and we can't have a negative distance. I get radical 2. So what that means is that that's the ratio that the sides are always in. The legs are always the same, and the hypotenuse is the same with a radical 2 tacked on. So that's where we come up with what's on the reference sheet. 45, 45. The two legs we're going to call x, and then the hypotenuse we're going to call x rad 2. This is bothering me. It looks like it says 26 and 13. So let's recap what we talked about so far. For the 30, 60, 90, the small leg is always half of the hypotenuse. The hypotenuse is double the small leg. And the large leg is the same as the small leg with a rad 3 tacked onto it. Again, small leg, half of the big the hypotenuse, or hypotenuse double the small leg. And then the large leg is the same as the small leg with a radical 3 tacked on. For the 45, 45, 90, the legs are the same, and then the hypotenuse is the same with a radical 2 tacked on. The legs are the same. The hypotenuse is the same with a radical 2 tacked on. So the key understanding here is if you see a right triangle with a 30, 45, or 60, you're supposed to use these special right triangle ratios. And once you know one side, you have all three. So let's take a look at the first example. It's a 45, 45, 90. So for the 45, 45, 90, I know that my legs are the same, and the hypotenuse is the same with a radical 2 tacked on. So if this side is 3, then the other leg is 3. And the hypotenuse is 3 with a radical 2. And that would be your answer. These are not difficult, it's just a matter of recognizing it and knowing it. Try number 2 on your own. Look back to number 1 as a model if you need. Give it another 10 seconds. So, since the 45, 45, 90, I know that the legs are the same, and the hypotenuse is the same with a radical 2 tacked on. So if this leg is 7, then this leg is 7, and the hypotenuse is 7 rad 2. Number 3, I see 45, 45, 90, so I know that the legs are the same, and the hypotenuse is the same as that with a radical 2 tacked on. So, since this is 10 radical 2, then the legs are going to just drop the radical 2 and be 10 and 10. Now, the 30, 60, 90. The 30 is opposite the small leg, and the 60 is opposite the large leg, and the small leg is half of the hypotenuse. The large leg is the small leg with a rad 3 tacked on. So it's giving me the small leg, so I like to start with the hypotenuse. The hypotenuse is double that, and then the large leg is the small leg with a radical 3 tacked on. So since the small leg is 5, the large leg is 5 rad 3. And again, the small leg is opposite the 30, and the large leg is opposite the 60. I see a 30, 60, 90. So the small leg is half of the hypotenuse. The large leg is the small leg with a rad 3 tacked on. So it's giving me the hypotenuse. I know that the small leg is half of that, which is going to be 10. And then I know that the large leg is the same as the small leg with a rad 3 tacked on. So it's 10 rad 3. Once you know one leg, once you know one side of a special right triangle, you know them all. Again, I see a 30, 60, 90. So I can write down my special general form. The small leg is half of the hypotenuse. The large leg is the same as the small leg with a rad 3 tacked on. So, since this side corresponds to this side, that's saying that my x, my small side, is 8. My hypotenuse is double the small leg. And those would be my answers. So, again, whenever I see 30, 45, or 60, I'm going to use these given special right triangles, understand what they mean. First of all, the small leg is opposite the 30, and the large leg is opposite the 60. The small leg is half of the hypotenuse, or the hypotenuse is double the small leg, and the large leg is the small leg with a rad 3 tacked on. For the 45, 45, 90, the sides are the same, and the hypotenuse is the same value as that with a radical 2 tacked on. So why don't you try numbers 7 and 8 on your own right now. They're a little crooked, just a little hint. Once you have one, you have the other. If one of the angles is 45, then it's a 45, 45, 90. If one of the angles is 30, then it's got to be a 30, 60, 90. So why don't you try 7 and 8 on your own right now? So please pause, try 7 and 8 on your own, and then unpause. Okay, now that you tried 7 and 8 on your own, 45, 45, 90. The sides are the same. The hypotenuse is the same as that with a rad 2 tacked on. So if this side is 7, then the other leg is 7, and the hypotenuse is 7 rad 2. 30, 60, 90 just gets a little crooked. It's all about what's opposite what. So 30 is opposite the small leg, 60 is opposite the big leg, the small leg is half of the hypotenuse, or the hypotenuse is double the small leg. The large leg is the small leg with a rad 3 tacked on. So this 12 rad 3 is opposite the 60, so it corresponds to that, which makes x the small leg 12, and the hypotenuse double that, 24. So there's just a few more examples here. Your classwork / homework is to finish this. Again, when you see a 30, 45, or 60 in a right triangle, you need to recognize that as your special right triangles. Utilize the ratios, and once you have one side, you'll be able to fill in all three, the additional two, using these ratios. Have a great day, everybody.